What's worse than a customer with a failed condensate pump? How about an angry customer with a flood? Mars has designed a new condensate pump that will allow you to cross that concern off your worry list. Every feature critical to quality has been scrutinized, and every mode of failure has been studied. The result is this pump I have here in front of me. Let's take a look at what makes this arguably the most reliable and powerful pump in the world. First of all, the tank and the upper housing are all molded of ABS composite material. This means that the pump will not likely arrive at the job site broken. In back, the tank has integrated hanging feet. Nice feature in that additional hardware is not required to mount this on a vertical surface. On the bottom, this tank has vibration-absorbing feet. This isolates the pump from a hard surface, keeps it quiet, and keeps it from wanting to walk around. On the upper deck, we have 3 condensate inlets to maximize versatility on the installation, as well as a standard 3/8" discharge. Now this Mars pump has a really unique check valve system. It's a quick release design. As you can see, I'm taking this check valve out right now with no tools. So we can service it, and we can put that check valve back in real quickly, again with no tools. The fact that I don't have to loosen the clamp means the likelihood of a leak has been minimized. The check valve is a silicone duckbill design, which is very reliable. Up on top, we have a 1/25 horsepower ball bearing motor. Yeah, I said ball bearing. Condensate pumps typically have a sleeve bearing design, and these can become noisy over time. The ball bearing motor will remain quiet for its entire life. Speaking of life, this particular pump has a life expectancy of about 10 times that of a standard competitive condensate pump. Now with a motor like this, you can expect a little bit of heat to come out the top, and the engineers have integrated an airfoil, an aerodynamic slider here that discharges the hot air away from the intake of the pump. Pretty thoughtful engineering there. Performance is expected to be great, and again with a 1/25 horsepower motor, this pump does not fail to deliver. The rated lift is 24 feet on this pump. And the volume of fluid that it will pump is 43 gallons per hour at 20 feet. That's about 4 times more than the competitive condensate pump. Okay, let's take a look inside this pump and see what makes it so reliable. First of all, you'll notice that the float is actually a composite plastic. And I like that for 2 reasons. First of all, the composite will not become waterlogged and actually sink like the foam designs often do. And secondly, this composite is impervious to acids and oils that are often found in the condensate fluid, so it won't degrade over time. Now this particular pump uses a 2-stage float mechanism. In stage number 1, or position number 1, the pump is in the on position and it's evacuating condensate. And in the unlikely event that the condensate level continues to rise to stage number 2, the internal safety switch will actually shut down the air conditioning system, and this will actually prevent a flood from occurring. Now on the bottom of the float, you'll see this standoff right here. And that's not a molding flaw, that's actually designed to keep the float from becoming stuck to the bottom of the tank. And you're probably asking yourself, well, why would a float ever become stuck to the bottom of a tank? Well, condensate pumps are notorious for developing organic sediment, or ick, if you will. And this ick can collect in the bottom of the reservoir and wreak havoc on floats. They can often become stuck in the down position, and they will not activate the pump then as the water rises. The standoff prevents that from happening. Speaking of sediment, let's take a look at the impeller. And gee, this is a sewage pump design. You can tell by the very thick and narrow veins that it has. It's designed to collect and evacuate not only condensate, but also the sediment that develops inside these tanks. It's pretty important to get the sediment out of there. We don't want this to continue to build up and eventually cause a check valve failure. You'll also notice that the hardware here is all stainless steel. In fact, everything that touches condensate is either going to be stainless steel or a composite plastic. And that ultimately spells durability. Okay, now for the moment you've been waiting for. Now, condensate pumps live in a very humid environment. I mean, they're always sitting on top of a basin of water. And this particular Mars pump has a feature called motor corrosion protection. And I think the only way to show how truly effective that may be is to do a demonstration for you. And so we're going to take our Mars pump and we're going to immerse it in a 10-gallon aquarium, and then we're going to let it run. And then to add one more piece of excitement to the equation, we're going to throw in Mr. Rogers, which is my mother-in-law's prized goldfish. And this is how much I trust this pump, because if something happens to Mr. Rogers, I'm in big trouble.